Hi guys, my name is Shahid. So today I want to introduce a fascinating concept that's quietly transforming industries around the world. A technology that combines real-world system with virtual simulations to create powerful insights and predictions. The topic is digital twins. As terms that sounds like something out of science fictions, but it's very real and increasingly common in today's tech landscape. By the end of this seminar, you will understood or you will see how digital twins are revolutionizing everything from smart cities and space missions to healthcare and car design even though. So first of all, we have to tell us about what is digital twins. A digital twin is a virtual replica of a physical object or process or a system. But it's not just a 3D model. It's a live, connected and real-time copy, receiving data from physical counterpart using sensors, IoTs and even AIs. It can be anything, a building a car, a power plant, or even the human body. The key point, whatever happens to the physical object is mirrored in the digital twin. That's the thing. And vice versa. We can test and predict things on the twin before applying them in real life. So we will go for some real life examples like Tesla and the cars. Tesla car, Tesla creates a digital twin for every car it sells. It's consistently receiving data from physical car like speed, braking patterns, battery health, and simulate those things, different driving conditions to predict potential issues. It constantly receiving issues. So by it's constantly receiving data, this helps them improve performance and even send over the air software updates. Okay, and another thing is NASA and the space missions. Like NASA was one of the first to use digital twin way back during Apollo 13 mission. Since you can't fly to space to check broken system, NASA creates a digital versions of the spacecraft to simulate the problems and find a solution in the real time. Today we use digital twins to monitor satellites and simulate complex space environments. Another thing is human care or healthcare and human digital twins. Like imagine we have a virtual twin of our body and doctors are working on creating digital twin on patients using medical records, imagining and genetic data. This can help predict diseases, personalize treatments and even simulate how our body might respond to specific medicines before prescribing it. So how does it work? That's the thing we have to think about. Like digital twins are rely on four major technologies. Like first of all, IoT or Internet of Things, like to collect real-time data from physical system. And another thing is cloud computing, like to store and processing huge volume of data. And another is AI and machine learning, like to analyze and make intelligent decisions. And another thing is 3D modeling to create a visual representation of our object. All this together build a system that learns, adapts and improves continuously. And I want to say the applications in different fields, like uh, some use case across the industries like smart cities, manufacturing, healthcare and aviation. Like in smart cities, cities like Singapore, Dubai are using digital twins to manage traffic, energy and even water supply. And so they even manage the pollution's level. They simulate the emergency situations like flood or fire outbreaks and plan efficient evacuation or resource distributions. And another thing in manufacture, like factories using digital twins of machines and productions line to predict failures, reduce downtime, and optimize efficiency. This is a core part of a industry 4.0. And another thing is healthcare, like already says that digital twins of hearts, lungs, and other organs being tested to practice surgeries virtually, reducing risk and increasing precisions. And in aviations like Airbus, using digital twins to monitor airplane parts and simulate flight conditions, and it ensures safely exits the life of the artifact. And like everything in my every seminar I will say like if benefits and challenges. So in this also some benefits and some challenges. That's a two part of everything we created. So first of all we will say about benefits. Cost saving, like avoiding real world failures saves millions, trillions, whatever it is. And faster development, like products can be tested virtually before launch. So another thing is better protections or predictions. It helps to forecast failures, weather conditions, and maintenance needs. And another thing is customization, like personalized treatment, personalized driving experience, personalized product testing. Those things helps customizations. And another thing is our challenges. This is the most important things. Like some of the challenges that's is data privacy. Like every time every seminar I always says about the data privacy. Like when person when personal or city-wide data is involved, privacy is a big concern. And the high cost, like initial implementation is very expensive or that much expensive to build these kind of data or these kind of things or these kind of digital twins. And another thing is complexity, like creating an accurate twin of a system like a human body is extremely difficult. And cybersecurity is a compromising digital twin could give attackers to control over the real system. And the future of digital twins, like experts believes that in future every person might have a personal digital twins for health monitoring. Cities have a urban twins for smarter planning. Digital twins will work along generative AI to create simulations where we never imagined. It's a future where virtual and real world boundaries blur, helping us to make better decisions faster. And to conclude, digital twins are more just tech buzzwords. They are shaping a future of innovations, efficiency, and personalization. From car you drive into cities you live in, and even body you are living. Digital twin could touch every part of our lives in coming years. So the next time you heard digital things, think of it not just a model, but as a smarter, evolving mirror of reality. Thank you guys. Thank you for your here.